In this video, I'm going to be explaining how to graph piecewise functions with different types of equations. These types of equations include linear, quadratic, and exponential functions, as well as functions with an absolute value and functions with a square root. I'm now going to write out an example of a piecewise function problem using 3 out of the 5 types of equations I just listed. The first function in this problem is y equals negative 2/3 x plus 2, where x is less than negative 5. This is an example of a linear piecewise function because it's in slope-intercept form, y equals mx plus b. The next function is y equals x squared plus 4x minus 5, where negative 5 is less than or equal to x, which is less than 3. This is a quadratic piecewise function, different from the linear function because it follows the standard form of a quadratic, y equals ax squared plus bx plus c. The last function in this problem is y equals 2 times the square root of x minus 3 plus 1, where x is greater than or equal to 3. This is an example of a square root function, obviously, because there's a square root over x minus 3. I'm now going to do some graphing, so I have to make a table with x and y values for each function. I'm going to start off with making a table for the first function, which is linear. The first thing I have to do is look in the brackets to see which x values I need to put in my table. Inside the brackets is the inequality x is less than negative 5. This means that I need to start the x column with a number that is less than negative 5. I chose to start it with negative 10. Since x is less than negative 5, the rest of my values on the table have to be less than negative 5. I decided to go up by 1 after negative 10 and stop when I reached negative 5. This means that the x values in this table are negative 10, negative 9, negative 8, negative 7, negative 6, and I'm going to make negative 5 the last number. I plugged negative 2/3 x plus 2 into my graphing calculator. You can easily find one online, and I wrote down the y value for each x value. The table said that the y value for negative 10 was 26 over 3, which is also 8.6 repeating. I rounded 8.6 repeating to the nearest tenth, making it 8.7. This makes it easier for me to graph. I filled in the rest of the y values, rounding all of the decimals to the nearest tenth. Now look above at the pink equation, the one we're working with. I know I already said this, but inside the brackets, it says that x is less than negative 5. This means that negative 5 is not included in the solution, but any number less than it is included. For this reason, I'm going to cross it off on the table, but we're still going to need it when we graph. Because negative 5 is not included, the coordinate negative 5, 5.3, is going to be plotted with an open circle. Basically, in summary, whenever there's no line underneath the inequality symbol, you use an open circle to plot. Also, just to be clear, I started with negative 10, 8.7 on my table, but there is an infinite number of coordinates before that. Negative 10, 8.7 also fits on my graph, so it's a good point to start with. I graphed the coordinate negative 10, 8.7 by estimating because there are no labeled decimals on this particular graph. I graphed the coordinate negative 9, 8 next, and continued with the other points. I plotted negative 5, 5.3 with an open circle, and I connected all the points with a straight line, and then I finally put an arrow at only one end of it. I moved on to the yellow equation, which is the quadratic. Inside the brackets, it says that negative 5 is less than or equal to x, which is less than 3. This inequality means that x is all of the values between negative 5 and 3, including negative 5. The x values in my table will be negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and finally 3. I did the same thing as before and plugged x squared plus 4x minus 5 into my graphing calculator, and I looked at the table with the x and y values. I copied down the y values into my table. Then I look back at the inequality in the bracket and I notice that the first inequality sign is less than or equal to. Whenever the inequality has a line under it, you graph it with a closed circle. So now I know that I need to plot the point negative 5, 0 with a closed circle. The second inequality sign, however, is different. It doesn't have a line underneath it, so I know that I need to graph the point 316 with an open circle. I'm now going to graph the first point, negative 5, 0, on my graph with a closed circle, as I've said many times. I plotted the rest of the coordinates on the graph, and I ended with plotting the last coordinate, 316. I connected all these points, but I didn't put arrows because the inequality tells me that the coordinates of this function do not lie beyond the graph. This is what my graph looks like so far, with both the linear and quadratic piecewise functions. Now I'm going to move on to the last function, which is the square root function that I colored green. Inside the brackets, it says that x is greater than or equal to 3. This means that I'm going to start my table with 3 in the x value column and go up by 1. To find the y values, I plugged 2 times the square root of x minus 3 plus 1 into my graphing calculator and copied the values from the calculator table into my table. I rounded all of the y values that were decimals to the nearest tenth. I'm going to look back in the brackets, and it says that x is greater than or equal to 3. The greater than or equal to sign means that I have to use a closed circle to plot the point 3, 1. After the point 3, 1, the coordinates never stop and go on for infinity, so I'm drawing an arrow. Now it's time to graph. I'm graphing 3, 1 with the closed circle, then 4, 3, then 5, 3.8, then 6, 4.5, and 7, 5. I only wrote down 5 coordinates in the table, but it seems like I can fit more on the graph, so I'm using the table on my calculator to plot the points I did not write down. I connected all of these points as best as I could and added an arrow at one side. This is my final work for this problem. Just to recap, the first function is linear, the second is quadratic, and the third is a square root function. I do not need to label each one on the graph. When you are graphing piecewise functions, don't forget to look at the inequality symbols to figure out if you need to graph a closed or open circle.